All right, thank you, Randy, and thank you again, Central Region, for providing this platform to be able to share some of these tools that have been coming out from the research and other operations communities. I'll tag on to what Aaron said. Speaking of a fire hose, I'm going to have several tools to show you today. And again, it is too much information. But what John Gordon, my MIC, and my former Sue Ted Funk has encouraged our office to do is to basically build up these short cases. And this presentation basically is a collection of several of those short cases that we've used at our office. So I'm going to show you, let me see if I can get to the next screen. There we go. First off, how the, and again, I should say with all these tools, they've all were how they were used in real time. So it's not like we went back in after the case and found all these different things that were going on. These were how they were used in real time. So I'll talk about the ModelCertainty tool, which is used in GFE and how it helped with a couple of headline decisions. The Ensemble Situational Awareness tool, the ESAT, and how it helped with a couple of heavy rain events. I'll show you some RGBs, which really are my passion. It took me a while to get used to them, but once we saw some interesting features in these composite RGB satellite imagery, it just really took off. Looking at some long-range severe guidance, and then some of the MRMS products that are available to be seen. And again, there's just a ton of new tools out there. I just encourage you to get on out and to take advantage and look at some of these. So first off, going into that ModelCertainty tool and how it helped with the freeze watch. We had an unusually warm winter in Louisville. The accumulated winter season severity index, the Aussie there on the left, that red diamond shows that it was a mild winter for a lot of the eastern US, but also that it was a record mild winter compared to that database of about 70 years worth of data. And you can see the platform, the plot there on the bottom left showing that we were indeed at the bottom, and it was a very easy winter. Normal snowfall at Louisville is about 12.5 inches, and we only had 3.5 inches. And me being a Florida boy coming up here about 10 years ago, even I missed some of the snow. I really wanted to see some snow, even shoveling it didn't matter to me. We did have a mid-April freeze, which was a little bit past our last freeze on average there for Standiford. The last freeze typically is April 3rd. But now we're getting into May, and first off, I'll give kudos to the Climate Prediction Center. We put out this tweet about a week before some freezing temperatures came out. They gave a real high probability of below normal temperatures going on, and we highlighted the potential for some frost and freezing, even possible then. So as we fast forward to a couple days before the event, now these two images actually were the period 2 before the event. So this was from my Friday morning mid-shift that I worked. But really, we had similar numbers from the Thursday morning mid-shift that I worked. And so we were looking at a 4th period warning potential. And if you've never used the ModelCertainty tool before, on the left, what's plotted is the probability that the minimum temperature is going to be less than or equal to 30 degrees based on the various models that are in the GFE database. And you see some of those models there, the NAM12, the bias corrected, lots of models that are available. What you see on the right is a combination of all the models and what their average low temperature is for the morning that we were expecting to freeze. And the star is where our forecast is, and you find that it's within the box, which is that 25th to 75th percentile, and well within that. So it's pretty good confidence that we were going to have some kind of a freeze over our area. So we were able to highlight that wording and collaborate with my neighbors, Wilmington and Jackson. We're equally confident, and we decided that we were going to go ahead and go straight to a 4th period freeze warning instead of even having a watch out. Just go straight to that warning to try to give as much lead time as we could to the confidence that we had. And so on the left, you see the plot that we put out that morning. Again, for the 4th period, we had the warnings up for all of Southwest Ohio, most of Eastern Kentucky. I think actually all of Eastern Kentucky, but they were also dealing with frost that morning, which is that medium shade of blue. And then we put out a freeze watch because Indianapolis didn't want to go with a warning just yet, and we didn't quite have the same confidence level as we did in our eastern zones. And again, we highlighted that it was a significant impact for agricultural interests, and we put as much wording as we could into the AFD. And again, the latest freeze on record for Louisville was May 10th. So this being May 9th, this was a very unusual event. Then the morning of May 9th, we put out this tweet about 5 in the morning, just talking about how atypical it is, nearly 2 hours before sunrise, to have temperatures even in the upper 20s for some locations. And on the right, this is how it verified the actual low temperatures from that morning. Several weeks later, we talked to the UK Ag Department. We have a good relationship with them. They keep us abreast of when plants are sensitive, when the various crops are sensitive to freezes. And we deal with them both in the spring and in the fall season. And they gave us a report of what happened, some moderate to severe damage to several of the growing crops out there. But there's an unknown amount, how much was really saved thanks to that early warning. I know on my drive home from work, there's a garden place that sells lots of flowers and plants. And I noticed before the event happened that they had pulled a lot of their stuff in. So there's really no easy way to calculate how much was saved thanks to that early warning. But in my own yard, this is a Japanese maple tree that didn't fare so well. The mid-April freeze kind of hurt it, and then this early May freeze looks like it's killed it. So that's just I think I can finally get rid of that one now. So if you've never used ModelCertainty, here's just a brief primer. I'm not going to talk about this. Just let you, if you're watching the recording, you can go back to this later on and figure things out. Now I'm going to jump ahead to how we used it to help with a wind gust event, and I'll sort of turn the tables here, and this is the actual verification first. And for us, our wind advisory criteria is actually 40 miles an hour. Typically for other offices, it's 45 miles an hour. We have a little bit of a lower threshold, and that comes from emergency managers that say, hey, we really need help in our area when you get up to about 40 miles an hour. So several years ago, we lowered our criteria. And the yellow areas that are highlighted are roughly the areas that would have verified a wind advisory. So I worked the evening shift before this low-level mix-down event that happened the next morning. And there was some push from our media partners said, hey, there's some models out there that are saying 60-mile-an-hour winds are going to come down. You need to have some kind of a product out. And so I set looking out and trying to find a way to make a decision about where I wanted to go with some kind of advisory. I had a couple offices that said they weren't interested. So I had to try to match up with that. And here's what the ModelCertainty tool gave me when I applied it over a range of time. And I asked it, okay, what's the maximum wind gust that you expect during this range of time? I chose 34 knots to give a little bit of a threshold under that 40-mile-an-hour guidance that we have. And so here you see there's some likely values in my bluegrass area, which includes Lexington, points east of Louisville, and some chance range down there in the Bowling Green area in my southwest forecast area. Not as high as confidence as what we had with the previous discussion, but again, here's the plot showing you where our forecast is based on the other model data that we have to choose from. And we're a little bit outside of that box, still within the 10 to 90% whiskers that are on either end. And just from personal experience using this tool, I was comfortable having our star basically being a little bit above the box, because it just seems like a lot of models don't give that peak wind gust as being the really high value that you normally expect. I do want to point out that the NBM and the NBM experimental, the 4.0, are showing up in there as being even above the whiskers. And the model that the TV Met was talking about was that NAM-DNG going up to near 50 miles an hour on average. It had some 60-mile-an-hour gusts. So I was comfortable with the numbers that we had. And this is where we ended up going to the wind advisory. Kind of an odd-shaped wind advisory, but it matches up well with what the tool gave me. And Jackson was on board with going with a few of their counties. Wilmington, again, was one of those that had a 45-mile-an-hour advisory. But they did decide to upgrade their HWO to mention the threat for 40-mile-an-hour gusts. All right, so I'm going to shift gears now to use another tool that we like to see here at the office to try to give an awareness of what's going to happen in the next week. And this is the Ensemble Situational Awareness Tool, and how we used it with 2 winter rain events. One occurred at the end of the year last year, and one a few days later. And again, for reference, there's the web address. It's very helpful in making decisions and just being aware of what's coming up in the future. Particularly, I focused on the integrated water vapor transport. And so what you're looking at here on the screen, I don't know if you can see my arrow or not, but you can select the region. It usually defaults to the latest run. You can set the model run. I just pick LMK so that it focuses the box in this area. And what you're seeing on this table on the left is it's trying to pick out the highest, or whatever, the worst color that is in the plot, and it puts that here. So this is the integrated water vapor transport column as you go forward in time from the current forecast. And this is the 36-hour plot, and it's got that dark blue color in there, which is saying that the model is saying, actually what it's showing is that based on climatology, the integrated water vapor transport is the highest of all time, or at that 0Z time frame. And if you look at our other event and what it showed 36 hours before, it's showing the East Tennessee area and parts of the Deep South into that dark blue color. So there's a couple differences in this. One, we get a few of the hint that our Southeast CWA, again, we cover Central Kentucky, is at a threat. But I also like to look at these arrows, and it's pumping that moisture up into our area, whereas the arrows here are pumping it more into Eastern Kentucky. So as I move forward in time to the 24 hours, we jump up here to where, okay, we got a little bit darker color into our Southeast CWA, but the same thing over here for the second event. It seems like it's more focused in Eastern Tennessee and even Northern Alabama. And so what we ended up doing as an office, before I get to that, let me just show you one other thing that I like to look at. If you were to pull out the percentiles based on the GEFS, this shows you based on reforecast from about 30 years worth of data. Has the GEFS ever forecast levels at this height? And in this case, we're looking at precipitable waters. And for this event, it showed that it had never forecast this high of an amount for this time of the year. And for the second event, it was, again, focusing more on Tennessee and Northern Alabama. So what did we do? We issued a flood watch for the first event, got ahead of it, but we decided not to issue a flood watch for the second event. And what verified is what you see here is the rainfall totals over 2 days for both events, and we had a widespread area of 2 to, in some cases, a little bit over 3 inches. The second event was a lot more of a stratiform rain and didn't produce nearly as much. We ended up not having any flood warnings for either event, but we did have several verified river flood warnings and flood advisories for this first event. We had issued a couple of river flood warnings for this event, but they didn't verify, so we had to back off. So again, this Ensemble Situational Awareness tool helped us to make those headline decisions for what was going to go on in our area. I wanted to throw in this, I almost forgot about it, but I had saved some imagery from Tropical Storm CRISTOBAL in early June. It's been a very active season, but this one in particular, I remember noticing if you use CONUS or Continental US as your scale, and then you click on the MSLP tab, in this case, this was 7.5 days out before the event happened. And this was even before the Hurricane Center had issued any kind of advisories on this storm. It was showing something off of the Louisiana coast. And you can also, from the website, the ESAT website, you can look at the European means, although I think you have to have your email credentials into the database there. And even the Euro ensembles was showing something going on there. And that signal persisted for several days, until it made landfall that Sunday evening. So that's just a really good point. And I did briefly look at what was going on with those 2 systems that are out in the Atlantic right now. And the ESAT right now is having trouble deciding. It doesn't have nearly as good of a uniformity in signal as it did for Tropical Storm CRISTOBAL for this one case. All right, so again, this is my passion going into the composite RGBs. Our office is really taken off as far as using this, and it's tough to get out of the mindset of just using straight IR or straight visible. But once you see some of the features that you can see in these composite RGBs, it just really takes off. And you can find these under the GOES menu in the satellite under the RGB composites. And there's a couple that I'll be showing you today. One is that nighttime microphysics that helps you to see hotspots. Another is that day cloud phase distinction. And this just makes for really good social media posts when you see some of the things that I'm going to show you. So here's a case from the nighttime microphysics RGB. And this actually hit close to home. I was working a midnight shift, and I live right about there in the middle of Oldham County. So when I saw that, it just sort of stood out. And I always have the nighttime microphysics RGB in one of my display panels somewhere. So even if I'm doing a forecast, if one of these signals, one of these spots jumps out, I can make a call to dispatch and say, hey, it looks like there's a fire going on. First thing I'll do though is I'll go to a Google map and try to see, okay, is that hotspot like over a power plant? Is it over someplace that maybe should be producing a hotspot? As we do see power plants all the time. In this case, it had a dot over Reformatory Lake, and there's a state prison off to the east of this picture. And so I was able to have some confidence to say, hey, when I called 911 dispatchers, have you heard any reports of a fire in this area? I gave them some cross streets. And in this case, they had heard of a structure fire that they were just then dispatching for. So I drove around to try to find, after the fact, after I woke up from my mid shift that next morning, I drove around trying to find where the fire was. And it was actually a little bit off what the pixels should be in the plot. I tried to match the pixels with exactly where it would be on a Google map. It's about 1 kilometer off. So when you, this is a Google size, an approximation of the pixel size from the nighttime RGB, about 3 kilometer by 2 kilometers squared. And so you can give them an approximate location, but you could just tell the people, hey, if you have any structures in that area, that you may look for a fire. And in the couple of years that I've been finding these fires, again, by eyeball, this is just by seeing it on satellite, we've had verification on about 50 out of 60 of those cases of actually being fires. And in one particular case, this was down in Adair County, in northern Adair County. We actually caught the fire ahead of time, and we told the dispatchers about where it was, and they found the barn on fire off of a rural road, and we got some good praise from the emergency manager, just saying that it helped to save a fire from becoming a larger wildland fire. So that really gets you hooked when you catch your first fire on satellite and you call down to dispatchers and they said they hadn't heard anything yet. It makes you interested in continuing to look for those things. And you can also see other things in nighttime microphysics. This really is good for looking for fog products. I won't go into details there. This was a winter case here from a couple years ago where you had a general stratiform layer over a lot of the Ohio Valley, but you see these darker shades, or not darker, but these brighter shades of yellow here streaming off of the Ohio River. And this is from a lot of the power plants that are along the river. And actually, I was amazed when I went to a talk, I think it was at NWA last year, by Jennifer Ketchmark, a TV meteorologist from Cincinnati, where she had somebody, it was an airplane, took this picture that was downstream of one of those power plants. And she had had some viewers call to complain that you had no snow in the forecast, yet I ended up with 4 inches of snow. And that was an extreme case, but still you can see that we would not have had snow in the forecast for this day, but there were some cases where these streamers had some impact. So there's just no telling what we're going to discover over the years of having this high resolution data set. And it's just really exciting to be able to see some of these features. Change over to the day cloud phase distinction RGB. I really like this one for being able to see when cells are starting to take on that more of an icy look aloft. You can see that with the IR cooling as well. But in this case in particular, a lot of the lower clouds are these light blue colors. When you start getting into that ice phase, mixed phase in the cloud, they turn into this green. And then finally, when you get to your cooler cloud tops, they turn yellow and then orange and red. And in this particular case, this helped us with our aviation forecasts. Each of our 4 sites are circled with their vicinities. And you had this convergent band of clouds associated with a front that was in the area. And we had something that was trying to develop near the Bluegrass Airport in Lexington, Kentucky. So in this case, I combined it with other GOES products like the lifted index from the sounder data. And this is showing a negative feed over this area, but not quite as negative over the Louisville area. So combining those two together, seeing where the cloud field was and seeing the downstream storms that were going on over Jackson's area, I decided to amend the TAF and throw in vicinity thunderstorms for a couple hours. So again, there's a lot of data out there to be able to use, and there's some really pretty pictures that can help you to learn some new things. In particular, the day cloud phase distinction shows snow on the ground as green. In this case, it helped us with an overachieving snow band to know we need to make some calls down to that county and find out what their snowfall totals were. And we issued that. And then here was just some neat social media fodder showing a snow band and what was going on downstream and how it really stabilized that low-level air mass and killed the Q field down below that. You guys will learn a lot more things as you string together, again, some of these interesting cases and present them to your office and just go on from there. I like to share a lot of the interesting things with the satellite focal points at all our neighboring offices, and they share back with me whenever they see something neat. All right, let's shift gears to another tool, and this is the SPC Chiclets and the CIPS severe guidance, and how they did with a early May derecho and the actual another event that happened the following day down in the Tennessee Valley. And if you haven't used them, the SPC Chiclets has been around for a little while. CIPS has actually upgraded to a new type of guidance that I really like there too. So I'm going to show you how those did in the days preceding both of these events. If you've never used the SPC Chiclets before, I never actually remember the website, but I just Google it and find it. It's usually the first thing that pops up. I'm kind of lazy on that. I don't bookmark everything. I just try to find it later. But what this plot is showing you is a combination of the supercell composite parameter from the CFS matched up on top of what it thinks of as QPF. What's going to actually be convective QPF? And anywhere where there's a lot of convective QPF matched up with the supercell composite parameter, if you have a lot of those, then it's going to color those days as these darker colors of red. Where you don't have a lot, you end up with these blues. So this top line, again, this is an image from later. I didn't get an image from the derecho event. But this top line is showing you the forecast on July 24th for 45 days out. The next line below that is the forecast from July 23rd. And so as you see in persistent signals, you can see these periods that have a higher chance for a severe weather outbreak. And they come in patches like this. And what's neat about this, if you were to click on one of these X's with the reds, you can actually see the verification as well. They'll have dots that show you what the SPC Storm Report database showed and how they match up. But in this particular case, there's not much going on in the first couple days. Now, if you were to click on the event back before the May 3rd derecho, here's what you would get, a CONUS map showing you the QPF, the convective QPF, and this SCP parameter. And where you see them matched up is where you have those, basically the total number of grid points that match up is how that other plot is made. And over the Tennessee Valley, day one of the event, it's showing this area that matches up, but it goes all the way back as a very persistent signal, even back to day 6 days before the event happened, about where the potential for some outbreak was. Jump over the CIPS severe and how it did with the same event, again, the May 3rd event. And also it had a very good location signal for each of the days before. Actually, it looked like it was a stronger signal in the days 4 through 5, and it became a little bit more focused as you got down to days 3 through 1. Now jump over to what SPC had. There was basically too low predictability there, and then they had, for the day 3 outlook, they went to general thunderstorm. And then they started to focus on that region and the potential that was there. Jump over to the May 4th event, and again, you see that same signal, broad area of this high SCP with the QPF in the background, and it went on for several days. It actually did a pretty good job with the location, a little bit better job than the previous one did with the location showing over the Tennessee Valley. CIPS severe, same thing. You're looking for this persistent signal, wasn't quite there at day 6, started to get in there at day 5, days 4, 3, 2, 1. It was showing a little bit better for the location of where the actual damage was. And SPC put out a day 4 graphic, basically for the generation area for where this was going to start going downstream. And then they had the slight risk, and then they had the tail going down into the southeast US. So again, for the combination of these two products, you want to look for these persistent signals, the shape and the focus area and how that might go into your area. We did put in storm chances in our HWO even at day 5 for the derecho event, and the rest of the office forecasters kept that in the HWO, despite what was not quite as heightened of a wording just yet from SPC. And one thing I tell our new meteorologists that are coming in repeatedly is if you have any thoughts about any kind of severe weather, message SPC and communicate your thoughts with them, and specifically during their collaboration windows. They do want to hear from you, and they do want to know your thoughts, and that you guys can have a good conversation about things that are going on in the NWS Collaborate room. All right, I'll wrap up with some MRMS stuff. And it just seemed like we always have busy weather in the Louisville CWA. I don't know why, especially my forecasters that I work with, we all think that it's always whenever I'm working. So it's a blue sky day. I've got a telework day here, and somehow it's quiet over our area. But in particular, we had 3 days of heavy rain ahead of what I'm going to show you next. And here's just a map showing the observed precipitation for that 3-day period. And you see a lot of greater than 2-inch totals in here. This is a bubble of 8 to 10 inches, 6 to 8 inches over a large area of our CWA. And our service hydrologist, Andrea Schuttmer, I think she was the one who pointed me toward this CREST soil moisture, which is the background map you see here. And this is a real-time estimate from MRMS of what your soil moisture is. And after that 3 days worth of rainfall, it was showing, basically matching up well with where those high rainfall total values were. It was showing the areas that were at most risk of being hydrophobic if you were to have a lot of rain falling over those areas. So the overlay here is the instantaneous rain rate from the MRMS. And it's showing that our CWA boundary is right about here. It's showing some heavier rains that are moving into the area with these rain rates of 4 to 6 inches. Moving right close to where that area of intense soil moisture is, or high soil moisture is, into the 40 to 70% range. But as you get toward the end of the frame, you notice it looks like it's trying to go a little bit north of where the heaviest rain had fallen. So I was using this to try to make decisions on whether we needed any kind of a flash flood warning, a quick flash flood warning because of how much rain we had in our area. Decided to hold off because it did end up going farther north, and it actually started to weaken as it continued on into this area. But we did have some new development over Breckenridge and Grayson County, and even later on into northeast Jefferson County, which had had quite a bit of rainfall. And so we issued some flood advisories and flood warnings down in those areas. And lastly, I almost forgot about this event too. Another one of those cases where we had a new tool and I was able to see something that helped us in real time. Some of you may not know you have this in AWIPS, but on the MRMS menu at the very bottom, there's a Prob subfreezing road temperature grid. And what it tells you is what is the percentage chance that your road's going to freeze. It's basically below freezing. So for this event, we had snow showers that were moving through overnight. And it was initially the road temperatures were above freezing. And we were expecting there to be gusty winds that would help to wipe off the road surfaces and keep them clean. But the MRMS data here showed you that the roads are cooling quickly, especially in the areas that were hit hardest by snow. And when I say hit hard, I mean less than a ½ inch of snow. It really doesn't take much snow in our area to cause some issues. The fortunate thing about this was that it happened overnight. So we had a couple of heavier showers in Henry County and over Jefferson County. But you can see some of these streamers that went into especially our Lexington metro area, which has a couple of interstates that crisscross right there. And anytime you have snow over those interstates, you worry about the potential for some slide-offs. Media here were keying on snow squalls, which we didn't really have. We didn't have the visibility down to a quarter mile. We didn't have initially the road temperatures cold enough to worry about. And what we had issues with Google Maps was that it was basically showing the traffic problems after the snow had fallen. So in this case, we really had more of a flash freeze event, which is what was showing by this road temperature grid occurring. So we were, since it was overnight, we issued several SPSs. We didn't go with any kind of a winter weather advisory for black ice because of the narrow area that had caused some concern and because it was a middle of the night lower impact event. So again, sorry to fire hose you with all these new tools, but again, if you just deal with them one at a time and case by case and present these cases to your staff, just do a short 3 or 4 page PowerPoint and get people excited about using some of the new tools that are out there. None of them's perfect. You have to use multiple. I was just reminded of that. I had a severe thunderstorm warning that I issued last week on an evening shift where the lightning data from GOES had nothing really standing out. The cloud tops weren't that cold. It was just a sudden updraft and sudden downdraft that caused some damage over South Central Kentucky. So you need to use multiple tools and just, at least try them. Get out there and try some of these things, especially the RGBs, and generate some interest in them by telling your staff what's going on, what do you see? And remember, especially for the satellites, there's a heavy investment that was paid for these satellites and putting into the programs. So pay that investment forward and use them for whatever you can. And just generate excitement among your partners and say, hey, this is what we're seeing. Let's see what we can do from there. So with that, if you have any questions, if I got some time, yeah, you can either ask them here or again, my email address is there. So Randy, back to you.